Welcome in 6th grade. In this video, we're going to be taking a look at your Eureka Workbook Module 2, Lesson 4. And at the beginning of this lesson, we have an opening exercise where they ask you to write at least 3 equivalent fractions for each of the fractions below. And you'll see 2 examples below there, 2/3 and 10/12. So to start off, I want y'all to take some time, think about what you've learned about fractions and see if you can come up with some equivalent fractions to these two right here. Okay, so we have 2 fractions here and we want to find at least 3 equivalent fractions for each. Okay, so first, equivalent. What does that mean? Well, equivalent just means equal to, right? So we want to find some fractions that are equal to 2/3. All right, so we need to understand some facts here that I wrote off to the side right here, and I'm going to talk about them right here, and I'll refer back to these throughout the lesson. Fractions are division problems. We talked about that in the last lesson. So 2/3 is really just 2 divided by 3. So 2/3 has a decimal representation that we can calculate, and I'm going to write this slightly different. 2/3 is a decimal representation that we can calculate. We can calculate this by hand, but I'm just going to pull out my handy-dandy calculator just to show you. 2 divided by 3. Now, obviously, that's not a perfect number right there. So, like 0.667. We're not going to go all the way with that extra 6 right there, right? So, approximately, it's equal to 0.667. So, what we need to do, and what it's asking us to do in this opening exercise, is to create equivalent fractions. Well, how do we create equivalent fractions? Well, let's refer back to these key ideas that I wrote out on the side right here. So, first of all, fractions are division problems. So 2/3 is really just 2 divided by 3, right? Now, any number can be written as a fraction. All right, so let's just stop right there. So let's talk about whole numbers. So for example, let's take a whole number like 2. Now there's a couple of different ways we can write 2 as a fraction. First, and the most easiest way to do this is to write it as 2/1. Any number over 1 is just equal to that number, right? Because again, we go back to the first key idea here. Fractions are just division problems. So let's put this into our calculator again. We have 2 divided by 1 is just equal to 2, right? So that's just to say that 2/1 is equal to 2. Cool. All right, so any number can be written as a fraction, and it has an infinite number of equal representations. All right, so that's what we're trying to get to right here now. We want to take this number right here, which is a number, it's a fraction, it's a number, and find out some equal representations of 2/3. All right, so how are we going to do that? Well, let's go to the third key idea right here. So any number, x, for example, any number, that could be a fraction, a decimal, any number, when you multiply it by 1 is equal to that number. And you've learned this before. Any number times 1 is just that number. 4 times 1 is 1. 2 times 1 is 1. If we multiply 2/3 times 1, that would equal 2/3. So how are we going to use this information right over here to help us come up with some equivalent fractions for these examples right here? Well, we know that any number can be written as a fraction, and that any number multiplied by 1 is the same as that number. So what we're going to try and do is we're going to multiply 2/3 times 1, but not just 1. We're going to multiply it by a different form of 1. We're going to write 1 as a fraction. So how would we write 1 as a fraction? Well, we could start by writing 1/1. 1/1 is just division problem. 1 divided by 1 is equal to 1. Now, is there another way we could write 1/1? What if we wrote it as 2/2? Are those two things equivalent? Is 1/1 equal to 2/2? Well, let's try it out. Again, a fraction is just a division problem. So 2 divided by 2 divided by 2. That's fantastic. 2 divided by 2 is just 1. So yes, we can say that 1 over 1 is equal to 2 over 2. Well, what other ways can we write 1? What about 3 over 3? 3 divided by 3 would be 1, right? All of these are equivalent fractions. So now what we can do is we can go back, and since we know that 1 is equal to 1 over 1, which is equal to 2 over 2, or 3 over 3, we can come back and we can replace this one that we're multiplying with over here with one of these. So instead of 1 or 1 over 1, let's go to 2 over 2. So let's go back to our rule. So we know that any number that we multiply by 1 is going to be equal to that number. Well, we're really just multiplying this fraction by 1. 2 over 2, again, is equal to 1. All right, so the rules when you're multiplying fractions. When you're multiplying fractions, you multiply the numerators times the numerators, and the denominators times the denominators. So go 2 times 2 is 4. That remains in the numerator spot. And 2 times 3 is 6. So what we have come up with here is 4 over 6. And what we are suggesting is that 2 over 3 is equal to 4 over 6. Now don't take my word for it because we can prove this, all right? So remember that fractions are just division problems. So let's go back. Let's take our handy dandy calculator right here. And let's figure out the decimal form of 2 divided by 3 again. Do this last time. Oh, all those numbers, that's not a safe number. Let's erase that. But we know it's 0.66 something, right? So 0.666 repeating forever, precisely. So now let's try 4. 4 divided by 6. 4 divided by 6. And bam, that gives us a decimal value that is equal to 2 over 3. So we have confirmed, check, these are equivalent fractions. All right, but it's asking for us for at least 3 of them, right? So maybe we can use this trend and we can keep going. Let's multiply 2/3 times, let's use 3 over 3 this time, right? 3 over 3 is equal to 1. When we multiply it times this number, it's not going to change its value. So we multiply 2 times 3, 6 over 3 times 3 is 9. So we have 2/3 or 6 and 6/9. Now I know some of you may have been able to do this in your head. But let's just do one more and we'll calculate it out just like we did the others. So we have 2/3. We're going to multiply it by another equivalent 1 fraction, right? So any number over itself, for example, 4 divided by 4 is just going to be 1. So this is an equivalent fraction 1. And again, we go back to rule 3. If we multiply any number by 1, it doesn't change its value, right? So we multiply the numerators. 2 times 4 is 8. Over 3 times 4, which is 12. So another equivalent fraction would be 8 over 12, which, including the original 1, 2 over 3, now gives us 4 equivalent fractions. And what I said before from rule 2 still applies right here. There are an infinite number of equivalent fractions to 2 over 3. We could continue this process forever and keep finding more equivalent fractions. If we multiplied it by 5 over 5, we would get 10 over 15, which would also be equal to 2/3. So with that in mind, let's move on to the second one, 10 over 12. Okay, so we can totally use this method that we used before, where we took the equivalent ones fractions and multiply it times the fraction down here. But one step that we can use, all right, so for example B, just to start with, we're going to use the same method that we used up here in example A to find some equivalent fractions. So we'll multiply 10/12 times 2 over 2 to start. That'll get us 20 over 24. 10 times 2, 12 times 2. So an equivalent fraction would be 20 over 24. Well, let's keep that going. Let's multiply this. I don't know, multiply this one times 2 over 2. We're just going to do it again. Since it's still multiplying by 1, 2 over 2 is still just 1. So when we multiply that, it's going to be the same value. 2 times 20 is 40. 2 times 24 is 48. These are some equivalent fractions. And again, these are just some examples. I know that some of you came up with some different ones, and those all look great. But another way we can do this, since 10 over 12 is not as simplified as it can be, we can also go backwards from this. So in example A, all we did was go up, make the numerator and the denominator bigger, but here we can actually make this numerator and denominator smaller. Now, whenever a numerator and denominator have a common factor, you can divide both of those by the same factor and get an equivalent reduced fraction. So in this case, 10 and 12 are both divisible by 2. So we can divide 10 by 2 and 12 by 2, and we can get an equivalent fraction. 10 divided by 2 is 5 over 12 divided by 2, which is 6. So another answer for this could be 5%. I know some of you may have already come up with that answer. That looks great. These are just some of the infinite possibilities that you could have come up with for these two problems. So again, these are just some of the solutions to these problems. There are literally an infinite number of equivalent fractions that these could be, but these are just the ones that I came up with. Did you come up with some different ones? Share them with me. Otherwise, we're going to be moving on. We're going to move to example 1, and I want to talk about this one together, because this goes back to lesson 3 in module 2. So in example 1, Molly has 1 3/8 cups of strawberries. Yay, yum, delicious. She needs 3/8 cups of strawberries to make a batch of muffins. All right, why not? How many batches can Molly make? They want us to use a model to support our answer. Well, so let's go back and let's think about the way we use division in the last lesson, right, to divide fractions. What this is really asking us here, since Molly needs 3/8 cup of strawberries to make a batch, they're asking us how many 3/8 cups of strawberries do we have? Well, we know that Molly has 1 whole cup and 3/8 cups of strawberries. So what we need to do is divide up what she has, her dividend, the total amount that she has, 1 3/8, divided by the amount she needs to make a batch of cupcakes, 3/8. All right, so you may recall in the last lesson, Mr. Shaheen telling you that he prefers improper fractions to mixed numbers, because in this situation right here, this mixed number is going to give us some problems when we're trying to solve this. So what we want to do, we need to remember our rules for turning mixed numbers into improper fractions. We're going to take the whole number and multiply it times the denominator. 1 times 8 is 8. And we're going to add that to the numerator. 3 plus 8 is 11. So we have 11/8. When we're doing this, the denominator remains. Nothing changed about the denominator. All we're doing is adding 8/8 to it. That's another way to think about this. So we have 1 and 3/8. That's all that 1 3/8 is, right? 1 plus 3/8 of another whole. So we could rewrite this 1 as 8/8, since 8 divided by 8 is 1. Follow me? I'm not blowing anybody's mind so far. Hopefully I'm not. We talked about this in the opening exercise. 8/8 is equal to 1. So now that this has a common denominator with 3/8, you may recall from 5th grade that you can only add fractions that have similar denominators. Well, look here. These guys do in fact have similar denominators. Now when we add fractions with similar denominators, all we're doing is adding the numerators together. So 8 plus 3 gets us 11/8. That's a couple of different ways to just think about turning 1 3/8 into 11/8. So we're going to rewrite this problem right here. 11/8 divided by 3/8. I actually want to go back and read this problem again, having rewritten 1 3/8 as 11/8. So now we know Molly has 11/8 cups of strawberries, and she needs 3/8 cups to make a batch of muffins. So how many 3/8 cups are we going to get out of 11/8? That's a great question. Well, we learned in the last one that when we divide fractions with common denominators, common units, that we can kind of essentially pretend that they don't exist, right? They're going to get factored out when we divide these fractions. So really what we have here is 11 divided by 3. 11/3. So that's to say that we're going to be able to make 11/3 batches of muffins. But you know, and I know, I hope you understand that we're not going to be able to make a fraction of a batch of muffins, right? But we know this is an improper fraction. So let's turn this, now let's go back and make this into a mixed number. So how many times is 3 going to go into 11? Well, 3 is going to go into 11 3 whole times, and that's going to get 3 times 3, which is 9. 11 minus 9 is 2. That means we have 2 as a remainder. We'll be able to make 3 whole batches with 2/3 of what we need to make another batch, right? So really we're only going to be able to make 3 whole batches here. But that's just the hard numbers part of this, right? They want us to create a model to support our answer. So let's do it like we did in the examples in the last lesson. Let's start with one full bar, right? And this full bar right here is going to represent 1 whole. Or if we divide this up into fractions, we're going to divide it into eighths. So 1, 2, 3, 4, 5, 6, 7, 8. And these will have 1, 2, 3, 4, 5, 6, 7, 8 parts of a whole. Now, how many parts of the whole do we have? We have 11/8, right? So 8/8 isn't enough. We're going to need to add 1, 2, 3 more eighths to be part of our game right here, right? All right, so now we have a total of 11/8 on the board right here. All right, and so we want to divide this up into groups of 3/8. Well, they're already broken up into eighths, so let's just start circling. We have one group of 3/8 right here, another 3/8 right there. We're going to swing and we're going to collect another one of these eighths right over here. And that's going to leave us with 2 left over, right? Because there's not a third eighth to add into this. So this is what's remainder. We have 2 eighths as a remainder, and we know that we would need this third eighth to get to a whole nother batch. So that means we have 2 of 3 parts that we need. 2 of 3 parts. So we have 1, 2, 3 whole groups of 3/8. So 3 whole groups with 2/3 of a group remaining. Now, the question remains, how many batches can Molly actually make? We're going to go ahead and assume that Molly can't whip up 2/3 of a batch. And we're just going to say, and if we write this in a full sentence, we would write, Molly can make 3 full batches. Now, as far as I'm concerned, that's a complete answer. It's a full sentence. It answers my question. She can make 3 full batches. Now, if you want to include what we have in the remainder here, we could say that Molly has 2/3 of what she needs to make another batch, or we could say she has she has a remainder. A remainder of what? What was actually left behind though? It wasn't actually 2/3, right? We had 2/8 over here remaining. We had 2/8 cup of strawberries left over. Remaining. That looks great. 2/8 cup, which could be simplified, you could say to 1/4. So she had 1/4 cup of strawberries remaining. All right, so this one was a little bit more complex. We had to do a little bit more work here, turning the mixed number into an improper fraction and back again. That's going to transition us nicely into example 2. I want you to take some time, read, and answer the question. Molly's friend Xavier also has 11/8 cups of strawberries. He needs 3/4 cups of strawberries to make a batch of tarts. How many batches can he make? Draw a model and support your solution. I'm going to give y'all 5 minutes to work on this independently, and we'll come back together and talk about this as a whole group. All right, cool. So Xavier already told us that 11/8 cups of strawberries is the same as what Molly had, which is convenient because we figured that out, right? We knew that Molly had 1 3/8 cups, which we knew was equal to 11/8 cups. So great, they have the same number of strawberries, right? But he's making something a little bit different this time. Xavier's making tarts. His recipe calls for 3/4 cups of strawberries. All right, so the real question is here, how many 3/4 cups do we have in 11/8 cups of strawberries? Well, let's draw a model to support our solution first, because I actually kind of like these models. I kind of like them, even though I don't know if this is exactly how Eureka would want me to do a model, but I like this little model right here. I like doing the one whole first. So this is one whole cup right here. And this is, each one of these blocks represents 1/8 of a cup, right? So 8 parts of a cup, right? And all of these are equal to 1/8 of a cup. But we have just 3 extra, right? So we have 9, 10, 11/8 cups of strawberries total. All right, and we need to figure out how many 3/4 cups we have here. Oh, but problem. What do we have here? We have 11/8 divided by 3/4. Well, I can't just start taking 3/4. Each one of these, if I took 3 of these, that wouldn't be 3/4, it would be 3/8. So what are we going to do here? Well, calm down, because what we can do is we can turn 3/4 into a fraction over 8. Well, how can we do that? We need these to have similar denominators, right? So we either need to divide 8 by 2 to get to 4, or multiply 4 by 2 to get to 8. Now, we could divide 8 by 2, but 11 doesn't divide perfectly by 2. So over here, we're going to transform this 3/4 into something over 8 by multiplying it by 2 over 2. Go back to the opening exercise that we use. When we multiply any fraction, any number, by 1, which 2 over 2 is equal to 1, it doesn't change its value. So when we multiply, we're going to get an equivalent fraction. We multiply numerators by numerators, denominators by denominators. 3 times 2 is 6. Over 4 times 2 is 8. So really we could say we're dividing 8/11ths into groups of 6/8. Oh, great. Now we have common denominators. Now we can mess with these. So we can come back to our model, and we know that we need 6/8. 6/8 cup of strawberries to make a tart. So let's circle one group of 6/8. Oh, that's a lot of strawberries. That's a lot more strawberries than it took to make the muffins. Wow, okay. Well, do we even have it? We have one batch worth. That's one batch. Are we going to have enough to make another batch? We have 1, 2, 3, 4, 5. So we're not going to have enough to make another batch. What we'll have left over is 5/6 of what we need, because this would be the last 8 that we need to make another batch. So what's left over is 5/6 of what we need, or you could say we have 5/8 of a cup. So two ways you go about writing your answer here is we could say Xavier has enough for one batch, for one whole batch, and we're going to assume again that Xavier can't make partial batches of tarts. So we have enough for one whole batch. Patch? You spell batch. For one whole batch with 5/8 cups remaining. Now again, we could say that he has enough to make 5/6 of a batch, but that phrasing seems a little odd to me. If we're not going to make a full batch, then it's pretty useless reference to it. So Xavier's going to make one batch, and he's going to be left with 5/8 cups, which he's going to put back in the fridge, or she's going to give to Molly so she can make some more cupcakes, right? All right, so we're going to move to example 3. It says find the quotient of 6/8 and 2/8. Use a model to show your answer. Now, you need to remember some of your math vocabulary here. What is a quotient? What does it mean when we find a quotient? That means we divided in something. So we divide 9 by 3. Its quotient is 3. It's like its solution, right? Now, we did plenty of examples like this in the last lesson where we're dividing fractions that have common denominators. You can use that rule. You can work it however you need to work it. You should use a model. I'm going to give you 2 minutes, 2-3 minutes. We're going to go ahead. Okay, and we're back. So we're going to divide. Now, I'm going to use my super secret shortcut since I taught it to myself now. And I already know that when we divide fractions that have common denominators, they are going to factor out. So they're essentially irrelevant here because they are common. Only because they are common. We couldn't do this with non-common denominators. But since they're common, we can just divide the numerators. 6 divided by 2. That's going to give us a fraction of 6/2. Now, look, Mr. Shaheen has told you in the past that he's okay with mixed numbers. But if the mixed number has a perfect solution like this, 6 divided by 2, then you can turn it into a whole number, right? 6/2 is equal to 3. That means 6/8 divided by 2/8 equals 3. Great. Now, let's make a model to represent that, right? So we'll have our bar again. We'll have 1, 2, 3, 4, 5, 6, 7, 8. So 8 equal parts of the whole. But we only need the quotient, the dividends worth, which the dividend in this case was 6/8, and we can ignore these 2/8 over here. So we have 6/8, and we want to break those into groups of 2/8. Well, let's start circling them. We have 2/8 right here, then we have 2/8 right here, and 2/8 right here. So how many groups of 2/8 do we have? We have 1, 2, 3 groups of 2/8. Hey, look at that. We come back and we find that our answers match. So 6/8 divided by, oh, that's fantastic. Like I was saying, we get 6/8 divided by 2/8 equals 3/8. Fantastic. Did you come up with something different? Let me know. And with that, we're going to go ahead and we're going to move forward. Example 4 is very similar to example 3, only this time we have non-common denominators. So what do you think you're going to do? I'm going to give you a minute. Let's discuss this as a class. How can we come up with a solution? Man, those are some awesome ideas. Wow. I'm really impressed. When I saw this problem the first time, this is what I was thinking. So just like we had done in the past here, we want to make these denominators be common because that makes dividing these fractions super easy, right? But 4 and 3 are not equal, right? Well, we can always find some equivalent fractions that have common denominators, yeah? So let's start by modeling our dividend. We'll draw a box to represent our whole, which will break up 1, 2, 3, 4, 5, 6, 7, 8, oh God, 9, 10, 11, 12. That represents our whole. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So here I have modeled a 12/12 bar. But remember, we only need 9/12 in our dividend. So what we're going to do is we're going to highlight 9/12, and we're going to pretend like this part doesn't exist. This is still part of the whole, but it's not part of our dividend. Now, we need to figure out how many groups of 8/12 we can divide out of our dividend. So we're going to circle 8/12. Well, each one of these is a 12, so we're just going to pick up 8 of them right here. And that's one group, one full group of 8/12 with 1 of 8 remaining. So we would need 7 more of these to make another 8th. Since we only have 1, that means we have 1/8 as a remainder. All right, so we worked together. We solved answer 4. You're going to come up with the answer 1 1/8 or 9/8. Either one of these answers is fine. And with that, we're going to move forward to exercises 1 through 5. Now, exercises 1 through 5 are very similar to the exercises we did at the end of class in the last lesson. Only this time you'll see, as you're scrolling down, as you're looking down on your page, that these fractions don't have common denominators. So your first step with all of these is going to be turning them into fractions with common denominators. And I'm going to give you, let's say, 5 minutes to work 1 through 5 independently, and then we'll come back as a class and we will discuss whole group. You're working, you're doing great. You pause the video maybe here. All right. Wow, guys, y'all are fantastic at this. Let's review, just for those who may have missed class, how we can solve some of these problems. So we have, in this first one, we have 6/2 divided by 3/4. We're going to want these to have common denominators, so 2 and 4. Well, I know I can multiply 2 times 2 to give me 4, so let me take 6/2, and I'll multiply it times 2/2. We multiply fractions, we multiply numerators times numerators, denominators times denominators. That's going to turn this into 12/4. So that's just to say that 6/2 is equal to 12/4. These are equivalent fractions. So we can come back and replace 6/2 with 12/4 divided by 3/4. Now that the denominators are common, I can factor out my denominators and just divide by numerators. 12 divided by 3, or 12/3. Again, since this does have a perfect solution, 12 can be divided by 3 evenly. What is it? 12 divided by 3 happens to be 4. So in this case, again, I wouldn't want you to leave this as an improper fraction because 12 can be divided by 3. So we get left with 4 right here, right? 12/3 is technically a correct answer. But with these, I expect you to know your basic math facts here. 12 divided by 3 is 4. All right, so let's move on to exercise 2. All right, this time we have 2/3 divided by 2/5. Very uncommon denominators, right? There's nothing specifically I can multiply. I can't just multiply 3 times 2 to get me to 5, right? But what I can do is take each of them individually, take 2/3 and 2/5 and turn them into equivalent fractions. by multiplying them by the other denominator. So 2/3, we'll multiply 3 times 5 to get us 15, and we'll multiply 5 times 3 to get us 15. Now remember, when we're multiplying these fractions, we really want to multiply by 1. So up here, we're going to multiply 2/3 times 5 over 5, which is going to give us an equivalent value, and we'll multiply 2/5 by 3/3, which is also 1, which is going to give us an equivalent value. So when we do this, we get 10, 2 times 5 is 10, 3 times 5 is 15. So 2/3 is equal to 10 over 15, and we have 3 times 2 is 6, and 5 times 3 is 15. 6/15 is equal to 2/5. Now, let's go back and rearrange these back into their original order. 2/3 was our dividend, which we changed into 10/15. And we're going to be dividing that by 6/15, which is our divisor. Common denominators, we can ignore them, and we're left with 10 over 6. Again, an improper fraction, and 6 doesn't go perfectly into 10, so technically this is a right answer, but we can simplify 10 over 6, right? They're both even numbers, and when they're both even numbers, we can divide them both by 2. So 10 divided by 2 is 5, 6 divided by 2 is 3. That's just to say that 10/6 is equal to 5/3, which is also equal to the mixed number 1 and 2/3. 3 goes into 5 one whole time with 2 as a remainder. So any one of these is technically a correct answer. I would prefer to see it as 5/3 rather than 10/6. Or if you answered it as 1 and 2/3, that's also acceptable. All right, problem 3. Let's go down a little bit so I can have a little bit more room to work. All right, so we have 7/8 divided by 1/2. All right, so we want these to have common denominators. 2 is a factor of 8. I know I can multiply 2 times 4 to give me 8, so why don't I just change 1/2 into a denominator of 8. So we'll multiply each part by 4. 1 times 4 is 4, 2 times 4 is 8. So 4/8 is equal to 1/2. Everybody agree with that? 4/8 is equal to 1/2? Great, great. I'm glad we don't have any complaining about that. We got 7/8 divided by our divisor 1/2, which we are replacing with 4/8. We can now factor out our denominators and simply divide our numerators. 7 over 4, which, if you are inclined to, we could turn into a mixed number. 4 goes into 7 one whole time with a remainder of 3. 7 minus 4 is 3, so a remainder of 3/4. So answers would include 7/4 and 1 3/4. Include but not limited to, right? Because there's a million different ways that we could write this. But you probably came up with one of these two answers. If you didn't, please let me know. All right. We have 3/5 divided by 1/4. So again, we want these to have common denominators. We're just going to multiply each one of the fractions by the other one's denominator to get a common multiple. So 3/5, multiply that by 4 over 4. Again, when we do this, we're not changing its value. And we're going to multiply 1/4 times 5 over 5. And when we do this, we get 3 times 4 is 12, over 4 times 5 is 20. 12/20 is equal to 3/5. 1 times 5 equals 5. 4 times 5 equals 20. So we have a dividend of 12/20 and a divisor of 5/20. They now have common denominators. We'll rewrite them in order. 3/5, 12/20 divided by 1/4 or 5/20. And from here, we're repeating the steps that we've done previously. We can factor out the denominators, and we get left with 12 divided by 5, or 12 over 5, which you could rewrite as 2 and 2/5. Let me know if you came up with a different improper fraction or a different mixed number. You may have missed a step going from the improper fraction to a mixed number. But if you got something other than these two, please let me know. Share it with the class so we can learn from each other's mistakes. Because I want to make plenty of mistakes too. All right, and for the last one, we have 5/4 divided by 1/3. All right, so again, we want these to have common denominators, so we're going to take them down here, and we're going to multiply each one of these fractions by the other one's denominators. So 5/4 we're going to multiply by 3 over 3. 1/3 will multiply by 4 over 4. And this will end up giving us common denominators. 3 times 5 is 15. 3 times 4 is 12, so 15/12 is equal to 5/4. And then 4 times 1 is 4. 3 times 4 is 12. 4/12 is equal to 1/3. And now we have common denominators. We're going to replace them back in the same order. Dividend is 4/5 or 5/4 or 15/12. And we're going to divide that by the divisor, 1/3 or 4/12. Now we can factor out our denominators and just divide our numerators. 15 divided by 4, or 15 over 4. And again, if you wanted to give yourself an extra step here, we can rewrite this. 4 doesn't go in 15 perfectly. We'll have 3 wholes with 3 fourths remaining. Oh, fantastic. So that, I believe, is the end of our classwork. Now you have the problem set. Problems 1 through 4 are just division problems. Some of them have common denominators, some of them don't. And that's it. That's all you have in a problem. Wow. Okay. I'm probably find some more work for you. All right. Thank y'all for giving me your attention. Thank you for your time.